Welcome to the Advanced Training course on IBM's Scalable Architecture for Financial Reporting, or SAFR. This is Module 11, Logic Table Introduction and Trace Facilities. Upon completion of this module, you should be able to understand the link between the workbench and the logic table, describe the purposes of the logic table and the logic table trace, define a function code, trace logic through a logic table, activate and use the logic table trace, debug a SAFR copy input view. The SAFR workbench allows users to create SAFR views. Once the view is saved and activated in the workbench, it can be used by the performance engine. A set of programs run using ZOS JCL. The performance engine program, GenevaERS, uses the view information in the SAFR metadata repository to create a logic table. The logic table contains the instructions that the SAFR extract engine, GenevaERS95, will use against the input data. The extract engine reads the source data, also called the event file, and the logic table instructs it what data to extract to create an output file called the extract file. Creating the logic table is similar to compiling a program. The view specifications are broken down into individual steps called logic table functions. For example, copying one field in a column from the source file to the output file typically creates at least one logic table function. Logic text for record selection may result in many logic table steps. Here are examples of main inputs and outputs to the extract engine. We'll explore these in more detail in this module. The logic table is like the source code for a program. By itself, it is static and does not change. The logic table trace is like running a program in a debugger, one instruction at a time. Instead of seeing the program on the screen, the debugger results are printed to a file, one record for each program instruction, showing the impact of each source or event file record on the program, and highlighting when and what kind of record is written to the output or extract file. The next few slides will give an overview of the major structures of the logic table. An example logic table will then be examined in detail, and later the results of the logic table trace will be shown. This is a simplified version of a logic table. The compiled instructions from the view are listed as separate rows in the logic table. Each row is numbered sequentially. These rows are used by the goTo rows. The goTo row 1 and the goTo row 2 specify which next logic table row should be executed based upon logic test results. Most often, goTo row 1 points to the row to be executed on a true condition, often the next sequential row, and goTo row 2 points to the row to be executed on a false condition, often skipping one or more rows. The function codes specify what action should be taken. For example, an HD function is the header for the logic table. The RENX means read next source record, and an NV is the start of a new view. Functions beginning with C compare two values, and functions beginning with W specify writing a record to the extract record. The ES and EN functions end the logic table. In this and the next 6 training modules, you'll be introduced to all the major logic table function codes. To help in remembering what each does, it is useful to remember the following naming rules. Each function code has a 2-character function, like LK for lookup or CF for compare field. Many have 1 character for the source, such as E for event file, L for lookup, or C for constant. Many also have 1 character specifying the target. Examples include CFEC, which compares a field, in this case comparing an event file field to a constant. LKL, which builds a lookup key from a looked up value. SKE, which builds a sort key from an event file field, or DTC, which builds a data column from a constant. The next part of the logic table is the sequence number. It is used only for certain logic table functions. It can contain either the extract file the record is to be written to, or the column number that required the logic table function. In this example, 1 is the extract file ID the extract record should be written to for the logic table write function WRIN. The next set of fields are the logical record LR and field IDs referenced by function code. For certain logic table functions which require an LR or field, these columns will contain the workbench ID for the LR or field used. These IDs can be located in the workbench. In this example, the NV new view logic table function is using the LR1264 as the event file for the view. The CFEC compare field logic table function is using field 63311 from the same LR as part of its comparison. The next set of columns specify the source attributes, such as the position of the source field in the event file, its length, its format, the content code, if it has one, and its decimal places. A full logic table report has a duplicate set of these columns for target or output attributes as well. Typically, these values come from the field assigned to an LR. POS is the starting position of the field. LEN is the field length. FM is the format of the field, such as alphanumeric or packed. CN is the date-time format, formerly known as the content code, which specifies the display format of a date or time field. D is the number of decimals implicit in the field number. In this example, the field 63311 starts in position 1 and is 9 bytes long. It is a zone decimal field format with no specified date time format and no implicit decimals. The last set of columns vary depending upon the logic table function code. For comparison functions, it contains the type of comparison to be performed, the length to be compared, and the constant to be compared against. In this example, the event file field is to be compared for an equal condition for 9 bytes to the constant of 522349999. Other function codes may display only the constant to be used in the function or other data. For this module, we will use a copy input view, view ID 3261, which simply copies the input records to the output file without reformatting them. In other words, the view copies the entire record from the input to output. A copy input view is used here because it is the simplest form of all Safr views. It does not require any columns or sort fields. We will examine the logic table created for this view throughout this module. A copy input view has the source record structure option selected on the View Properties tab in the workbench. If no filtering criteria is coded, all input records will be copied to the output file. Record filtering criteria can be used to select only certain records. In this example, the select if statement was coded in the logic text. It will result in only records with an input field legal entity equaling 522349999 being selected. The logic table shown is for view 3261, our copy input view. It is a complete logic table with only 7 logic table rows. The first logic table function in each logic table is an HD, or header function. This function causes startup functions to be performed, such as allocating memory and so on. Each logic table ends with an EN, or end function. The EN function ends all processing. Each event file to be read begins with an RENX, or readNext record function. The RENX function brings the next record to be processed into memory. All function codes following the RENX refer to this record. The file ID to be read is identified above the RENX. In this example, the file ID that can be located in the workbench for the physical file is 1284. Each RENX is paired with an ES or end of source file function. The Sapphire extract engine performs all of the functions between these two for every record within the file. In other words, when the extract engine reaches the ES function, it loops back to the RENX to read the next record in the source or event file. Each view begins with an NV or new view function. The NView function tests if the view has been disabled. For example, if an extract limit has been reached for the view. If so, all logic table functions for the view are skipped and the next view is processed. The NV is preceded by the view ID, in this case, view number 3261. Each NV is paired with a WR function of one type or another. A copy input view ends with a WRIN, write input record function. The sequence number in the WR functions indicate which extract file the records are to be written to. In between the NV and WR functions are optional functions to perform the logic required by the view. Most logic tables contain at least 5 to 10 logic table rows for logic. Our very simple copy input view, though, contains only one user-specified function, the CFEC function, a compare field, event file field to a constant. The CFEC row was created because the view contains a general selection logic text select if function. CF stands for compare field. The E in CFEC means event file field, a field on the input file. The event file field, the field to be tested, is the legal entity field from the LR1264 field ID 63311. That field is at position 1 for a length of 9 and zone decimal numeric format with no decimal places. The second C in CFEC stands for a constant. The type of comparison is an equals test, CMP equals 001, to the constant value of 522349999, which has a length of 9 bytes. The CFEC function uses the goto rows to indicate what should be done based upon the test. If the current event record constant comparison proves true, the row in the goto row 1 is executed. If the comparison is false, the goto row 2 will be executed. In our example, if the legal entity field contains a value of 522349999, execution continues at row 5, the WRIN function, which writes the input record. If legal entity contains another value, the comparison proves false, and the execution continues at goto row 5, the ES row. The ES function causes a loop to the RENX function, which causes the next event file record to be read. As explained earlier, the logic table is like a program listing, but it does not show how the program executes over time. A program in a debugger showing which logic paths are executed is like the logic table trace. In the extract phase, the MR95 trace function writes each executed row of the logic table to a report to aid you in debugging a view. The trace function can be selected and configured in MR95 parm, the MR95 parameter file. Trace shows how each record in the input file is processed through the logic of the logic table, one instruction at a time. The MR95 trace can become very large very quickly. Imagine that the input file contains 1 million records and the logic table has 1,000 rows. The total trace output could be 1 billion rows of printed data. Using the MR95 trace can also significantly impact performance. It should be used with care. Reducing the input event file size is the most effective way to control the performance of trace processing. When the trace parameter is set to y, additional parameters are available to control what is traced. If, for example, the file sizes cannot be reduced, these parameters can be used to reduce the trace output or isolate specific records or problems. The following are the more detailed trace control parameters. The trace input parameter will print in dump format the entire source record at read time. The view parameter will trace only for specific view. The LT function parameter will trace only a specific logic table function, like a CFEC function. The DD name will trace only that input file. From rec and through rec will trace from a specific record to a specific record in the input file. Similarly, from LT row and through LT row will trace only specific logic table rows. LT append will cause MR95 to produce a dump for debugging if it executes a specific logic table row, and message append will cause MR95 to append if it produces a specific error number, like an OC7 data exception. Lastly, the vpause, vlane, and value parameters trace only when the data at position for length on a source record is equal to a specific value. Although these functions are very powerful, they significantly increase GVB MR95 processing time, even if they suppress trace records from being printed to the output file. Therefore, reducing the file size is much more efficient if possible. We'll show examples of how to use them to find and fix problems in more detail in Module 15, Lookups and Constants and Symbolics. This is the logic table trace output. The first column contains the event DD name. This is the DD name of the event file, which contains the source data. If the extract engine is performing parallel processing, each row may show data from a different input file. The event record column shows the input record number from that event file. Because each input record is executed by numerous logic table rows, record 1, for example, shows multiple times in this output. The view and logic row columns show which logic table row execution is occurring. The row number is the sequential numbered row, the first column of the logic table. The value 1 and value 2 columns show the data used in things like comparisons. Value 1 typically shows the data from a file or a lookup, the E of a CFEC function, or L of a CFLC. Value 2 often shows a constant value from the logic text, the second C in both of these functions. Not shown in this example are the source and target attribute columns, which are similar to those in the logic table, containing the starting position, length, and format of the fields. This logic table trace shows what rows of the logic table were processed against each input record. In this example, event record 1 from event file was processed against NV, logic table row 3. Record 1 is then processed against logic table row 4. Later, after completing the loop for record 1, record 2 of the input file is processed against NV function logic table row 3. Some rows are not shown in the report, like the HD, RENX, ES, and EN rows. When record 1 is processed against the CFEC function on the logic table row 4, value 1 shows the value in the event record, the E in CFEC, and value 2 shows the constant in the logic text. The two values are equal, so the next row to be executed is the true row, or the go-to row 5. Execution continues at logic table row 5, the WRIN row, which copies the event record to the output file. When record 2 is processed against the CFEC function on the logic table row 4, the same pattern is repeated. Because the value in the file and the constant are equal, Processing continues with row 5 of the logic table, which writes the input record to the output file. On the third record, the CFEC comparison shows that the value in the event file record, ending in 731, is not equal to the constant ending in 999. Thus, the program jumps to the goto2 row, or false row, 6. Since this is the last record in the event file, the program ends at the ES row of the logic table. The record is not written to the output file. To recap, this logic table trace contains the following functions: CFEC, which compares a constant from the logic table to a field in the input file; WRIN, which writes the input record to the extract file. The logic table trace does not show HD, header function which begins each logic table; RENX, which moves a record from the input event file to the computer memory; ES, end of string, which is the end of the logic for a specific event file; EN, end of logic table, which is the last function of the logic table. The function provided by this view is very simple. However, because Sapher generates machine code, it is even more efficient than is available in COBOL. The CFEC function requires 2 single machine instructions. The assembler instructions generated from the COBOL if statement are typically many more. The same is true for the WRIN and RENX instructions. This gives Sapher a significant performance advantage. This is a list of the most common logic table functions and which training modules these will be discussed in for reference. This module provided an introduction to the logic table and trace. Now that you have completed this module, you should be able to understand the link between the workbench and the logic table, describe the purposes of the logic table and the logic table trace, define a function code, trace logic through a logic table, activate and use the logic table trace, debug a Sapher copy input view. Additional information about Sapher is available at the web addresses shown here. This concludes Module 11, Logic Table Introduction and Trace Facilities.